We expect you enjoy the workshop today and tomorrow, and do not hesitate to contact us as chairs for any question. Now, Jose will start chairing the next session by introducing our first keynote speaker. Jose, you have the floor now.
Okay, thank you very much. Thanks, Huáscar, for the introduction. Well, we are going to have a session, some papers before the first break. And as in previous editions of this workshop, we have covered risks of very different kinds. And some of you would say that perhaps we have covered things such as a deep learning model failing to detect another plane when you are in for instance, in some critical applications. And people might say that perhaps conversations are just words and they can't be dangerous, but just to change that conception, you still have that idea that conversational agents can't be dangerous. We have an expert on this topic today, Emily Dinan from Facebook AI Research in New York. She's been working on doing relevant research on several issues around conversational AI. Today they are boosted by massive models, but who knows what's going to come in the future. So we need to anticipate. That's why safety is so important. The risks, especially fairness, but also some other safety issues, and some of them inherited from the training data, and some others perhaps inherited from the way these models or these conversational agents are deployed or used. So I think it's a pleasure for me to have Emily today here. So the ground is yours. Thank you very much.
Thank you so much for inviting me, and I'm super excited to be here today at the workshop on AI safety. And I'm going to discuss, as Jose mentioned, chatbot safety. So this is joint work with several collaborators, Gavin Abercrombie, Stevie Bergman, Shannon Spruitt, Dirk Hovey, Ilan Barreau, and Verena Rieser. So just a preview of what I'm going to talk about today. First, I'm going to give a background, some background on the problem. So what is a chatbot and what is safety for chatbots? And then I'm going to dive a little deeper into the problem landscape and then center around why is this problem challenging? And then if our chatbots are unsafe, when is it okay to release models? Finally, I'm going to discuss some tools for measuring the safety of chatbots, and then discuss some exciting future research directions that would aid in creating better behaved chatbots. So as promised, first I'll start off with some background. And because this is a super interdisciplinary workshop, I'm going to explain exactly what I mean when I say chatbot. So many people are familiar with chatbots in their everyday lives in the form of assistants. So Siri or Alexa, for example, can tell you what the weather is, but they probably can't have a conversation like the one you see on my screen here. So for the purposes of this talk, we are interested in end-to-end agents that can talk about everything and anything, hence the word open in open domain. And our ultimate goal with this kind of research is to create a superhuman conversationalist. So if you can't actually read the conversation on the right, it's in a bit small font. This is a conversation I had with a model trained by my team at FAIR. And we start off talking about surfing, and then we discuss where we live. I say I live in New York, and the bot claims to live in Hawaii. And then we start discussing music and some famous historical composers. And so you can see the conversation naturally flows from topic to topic in the way that humans converse with one another during a chit-chat conversation. And there have been a lot of recent developments in end-to-end neural models trained on open domain dialogue data from the internet in the last several years. So a couple of years ago, we got Dialogue GPT from Microsoft. 2 Januaries ago, Google came out with a paper about a chatbot called Nina. And then my team at FAIR just over a year ago released BlenderBot. And every single one of these is a large scale transformer with slightly different architecture variations. And they are all likely trained on a dump of Reddit data from the internet. And some of them are fine-tuned further on smaller conversational data sets. But in summary, they're big transformers trained on lots of data, and they're pretty good at conversation. So just to put into context how much progress has been made in the last couple of years in this research, this is a graphic pulled from a blog post describing our release of BlenderBot. So just a few years ago, we were training dialogue models in this sort of key value memory network style. And on the y-axis here, we see the percent of conversations that were preferred over humans. So KVMMN was preferred a paltry 22% of the time, which is not nothing, but it's, you probably don't want to talk to that model. And then over on the right here, BlenderBot's at 49%. So roughly equal to humans in this evaluation setup. And in this evaluation setup is kind of a key phrase here because it's only measuring sort of short conversations where you don't go too deep into any topic. And we know we're actually very far from human performance along a lot of different axes. So in summary, these large seek-to-seek models trained on corpora of human interactions will learn patterns and mimic behaviors therein, such as how to have a chit-chat conversation. But unfortunately, this often includes offensive behavior and other unwanted biases. So this brings me to the problem landscape. What is safety for end-to-end conversational AI? So in this talk, I'm going to consider harmful system behavior that can lead to negative short-term impact, such as the user feeling insulted, and also long-term harm, such as negative societal stereotypes being reinforced. And we're going to consider three broad categories. The first one I'm going to call the instigator or Tay effect. So this refers to the phenomenon in which a system itself generates harmful content. And it's named after the famous chatbot Tay that was released on Twitter by Microsoft in 2016. So you can see a screenshot from Twitter of Tay on the left here. And Tay was learning online from its interactions with humans. And I believe it was 4chan users who caught wind of this and sort of came in and spoiled Tay's training data so that Tay started saying a bunch of offensive stuff. This is actually one of the least bad things Tay said. And it was shut down after, I think, like 16 hours. More recently, on the right here, this is also a screenshot from Twitter that someone posted, some continuations of GPT-3 that are representing harmful stereotypes. So why does this happen? Why do these models say these offensive things? So models trained on large data sets have been shown to replicate and even amplify harmful content in the data set. So if you recall the three models I discussed that were released recently, DialogueGPT, Mina, and BlenderBot, they're all trained on Reddit data, which, as you probably know, has a bunch of offensive content. But this phenomenon is actually not limited to end-to-end models. Like Tay, for example, was probably not end-to-end, although the exact architecture details are not clear. And it's not even limited to conversational models. So I showed the GPT-3 example, and GPT-3 is can be used for conversation, but is not really a chatbot in the typical sense. The next effect I'm going to talk about is the Yea-Sayer or the ELIZA effect. And this refers to when the system responds inappropriately to harmful content. So according to the creator of Mitsuku, which is a popular chatbot, abusive messages, swearing, and sex talk account for around 30% of the input received by Mitsuku. You can read more about it in this Medium blog post here. And chatbots don't always respond appropriately to this content. So a Yea-Sayer is a person who habitually agrees uncritically. And we see this at play a lot with chatbots, especially ones that are fine-tuned on these sort of pleasant chit-chat conversations. They have a tendency to agree with the user regardless of what they say. And when they don't understand the content, they often parrot it back directly. This was also named after the chatbot ELIZA, which was a computer program created in the 60s that was using pattern matching to be able to respond to humans. So it wasn't displaying any real notion of language understanding here. An example of the Yea-Sayer effect is shown on the screen on the left here, where a person says a harmful stereotype about women, saying women are not as good with numbers as men, and the chatbot just responds, yes, that's true. Yes, that's true. And I want to note that saying yes, that's true in and of itself is not offensive. So none of our offensive language classifiers or hate speech classifiers would fire on that sentence. However, it's only offensive in response to this context here. And we can take the same input and the chatbot doesn't respond yes, but it responds, I'm not sure about that, but I do know that ... And I want to flag that this is also inappropriate. So with our human conversational partners, at least, if somebody says hate speech, we would expect our conversation partner to explicitly negate that hate speech and not just not agree with it. So a response can be inappropriate even if it doesn't explicitly agree. So why does this happen? I kind of hinted at that with the name ELIZA, but the system really lacks true language understanding. And as I mentioned, popular models tend to agree with users and parrot back their input. Unlike the Tay effect, this phenomenon is unique to conversation, whereby meaning is actively constructed in the context between two or more speakers. So like I showed with the previous example, yes, that's true, fine on its own, but offensive within the context of this conversation. The third and final effect I'm going to describe today is the impostor effect. So this refers to the phenomenon in which the system provides unsafe counsel in safety critical situations. So this example shown on the screen is a conversation I had with Blunderbot, which is the model trained by my team. And I asked Blunderbot if I can mix Xanax with alcohol, and Blunderbot says yes, which, as we know, is really terrible medical advice. And for me, I obviously knew that I shouldn't solicit medical advice from a chatbot, but users may not know the limitations of these systems. They may seek medical advice, financial advice, or legal advice from these systems. So we already, this may seem silly, but we already know that medical chatbots are being deployed out there in the wild, including like mental health chatbots, for example. And while the Tay and ELIZA effects can be subjective, so what is offensive to me may or may not be offensive to you, the imposter effect may have objectively measurable negative impact, such as physical harm. So just as a quick summary, the instigator effect refers to when the system generates harmful content. The Yea-Sayer refers to when the system responds inappropriately to harmful content. And the imposter effect refers to the phenomenon in which the system provides unsafe counsel in safety critical situations. So I want to note that this is actually not really a comprehensive taxonomy. So we're explicitly not including controversial topics. So you can imagine certain topics in conversation can offend even if they're not explicitly toxic. So for example, discussing religion if your conversation partner doesn't share your views. We also exclude notions of bias and fairness as they relate to system performance. We do include notions of bias and fairness as they relate to propagating harmful stereotypes. And we don't include privacy leaks. So there's been a bunch of work recently about how these large language models trained on data scraped from the internet can memorize the training data, which can include personally identifiable information. And we also don't include environmental considerations. So there's been a bunch of work recently as well about the environmental costs incurred from training these really large language models on tons of GPUs. And finally, we're also not going to dive into trust and relationships. So you can consider, for example, there's a popular movie, Her, in which the star of the movie forms a relationship with their personal assistant. And it's actually not just sci-fi anymore. People are forming relationships with chatbots. And we're not going to dive into whether or not that's harmful in this talk here today. And this list in itself is also probably not comprehensive. You can probably imagine plenty of other harms that could result from chatbots. So why is this problem hard? Why can't we just create safe chatbots? Well, first, training safer chatbots presents a host of technical challenges. So detecting offensive language requires a really high degree of language understanding. And in particular in conversation, it requires the model to understand the full conversational context. You can imagine something can be super offensive without actually using any swear words or slurs. Controlling natural language generation is also an unsolved open problem. So say we can detect what's offensive, how do we control the model output such that it doesn't respond with anything offensive? And both of these things require a grasp of common sense and cultural norms that is well beyond current capabilities. For this reason, we'll refer to this problem as AI complete. So solving it won't be possible until AI itself is solved. But it also presents several social and ethical challenges. So firstly, safety, the very notion of safety itself is ill-defined. It's a contextual notion, so it varies from culture to culture, even when those cultures share the same language. And it also varies from person to person. So like I said earlier, what is offensive to me may or may not be offensive to you and vice versa. It's also a changing notion. So it shifts over time as language evolves, and also new personal and cultural events provide new context for the usage of that language. So a really salient example is the current pandemic that we're living through. The advice from a chatbot to go outside and hang out with all your friends would have been fine a couple of years ago, but may not be safe today, and in particular in settings where a locality is on lockdown and may actually even be illegal. It's also uncertain, and this is particularly true for researchers who aren't building products and are just publishing papers and whatnot. So the downstream effects of our research are unclear. So these values are changing, uncertain, but they're also often conflicting. So we can imagine trading off the values of loneliness versus privacy. And again, this is relevant to the current pandemic. So this is an article published by Cade Metz about virtual friends and digital companions. And so you can imagine we could probably help with the problem of loneliness for a lot of people if they were able to have a virtual companion, but it's sort of at what cost? A virtual companion has to remember lots of personal details about you. And so we may be sacrificing these users' privacies. So this is an example of a direct conflict between values. But values can conflict in other ways. So if my group of researchers has limited time to tackle all of the problems in AI, which ones are we going to target? So one example is that my team has really focused on safety, but we haven't really produced new research on environmental considerations. And this is kind of, like a false trade-off here in the sense that one team could probably do both of these things, but we see it actively happening. Like the entire AI community isn't working on green AI at the moment. So this is an example of competition for resources. And again, values can conflict in several other ways. So there can be disparities between stakeholders, such as who bears the costs and who reaps the rewards. This is relevant to environmental considerations, where these large tech companies that are largely based in the United States are reaping the costs of training these huge language models, but the effects of environmental harm are felt in places across the globe. It can also include intertemporal conflicts. So a person may pay the cost and reap rewards at different times. And another salient example is autonomy versus satisfaction. So back to the idea of a virtual companion. You can imagine creating a virtual companion that sort of indulges everything you say, or is a Yea-Sayer, even harmful habits. And so would such a companion have to be regulated, like in the way drugs are regulated, or would it be left up to the user to decide for themselves how they want to interact with it? So how do we move forward with these changing, uncertain, and often conflicting values? So one set of principles that we found useful when thinking about these problems is value-sensitive design. So this is a theory that incorporates human values throughout the design process for technology. And value-sensitive design consists of an iterative process of conceptual exploration, so imagining values, stakeholders, and possible trade-offs between values. And then empirical investigation, so conducting surveys, interviews, gathering wider viewpoints. And finally, technical investigation. So actually evaluating empirically how technology supports or hinders given values. Value-sensitive design, however, is largely based on the assumptions that values and trade-offs can be estimated early in the design process. But this is often not the case, especially for research. So we don't see too many examples of large-scale chatbots out there, although they exist. And so it's often unclear how our research is going to be used, say 10 years down the line. This is why we advocate for designing with a focus on flexibility, adaptability, and robustness to changing values. So this theory is nice, but how do I actually apply these principles practically in my research on end-to-end conversational AI? Which brings me to the next part of my talk, where I'm going to discuss how and when researchers should release models. So this has been a topic that's been gaining interest in the research community lately. So provided the known harms of these models, as well as the potential for unknown harms, how and when should I release my research? Is a question that many people have been wrestling with recently. And this question isn't unique to chatbots, and it isn't unique to the AI community. So see, for example, this article by the Partnership on AI about debate in virology about publication norms. So the trade-off there is open research versus potential biosecurity risks. And this is a really interesting article discussing what AI can learn from this. And back down to the chatbot community, so we can already see researchers explicitly making these trade-offs. So Mina, as I mentioned, is a model trained by folks from Google that was published as a paper. And this is, again, a large-scale end-to-end chatbot model. And in a blog where the researchers describe this model, they explicitly posit safety and bias as a reason for neither releasing the model weights nor releasing a demo which users can interact with. And so the question that presumably the researchers were wrestling with here is navigating the trade-offs between different values, such as open reproducible research and ensuring safe use. So for example, by not releasing the model weights, different labs were not able to make progress on top of this research. And in particular, it prevented progress on issues such as safety or bias. And I'm not going to talk about which trade-offs people should make, because it depends on the context of the particular situation and different values that people decide are important to them. Instead, I'm going to discuss a framework for how we can make these decisions moving forward in a more principled manner. So I'm going to go through each of these 8 steps and describe briefly what they consist of. So the first step is intended use. So this is in which researchers are encouraged to explicitly state their intentions for their research and consider whether this intention is positive, and what does positive even mean in this particular context. We also encourage researchers to consider what are the unintended uses. So say I want to release my model to the research community, but then somebody takes it and puts it in a chatbot that talks to thousands of people and says really offensive things. That would be considered an unintended use case. And while this step is really simple, it's really important to kind of ground these discussions in what exactly you're trying to do to help you design policies to sort of bolster the positive use cases and limit the negative ones. Next, we encourage researchers to think about their audience. So who is going to use this model? And again, it's important to consider the intended and unintended audience. And how big is the audience? So the policies I design will be very different if only 20 people are going to use this model versus millions. Next, it's important to consider the demographic composition. So for example, what language will people be using when they interact with the model? As for example, notions of offensiveness differ from language to language. And another example is, will kids use it? So certain topics may be appropriate to speak with adults about, but not children. And lastly, familiarity with NLP and machine learning is really important. So back to the example I gave where I asked Blunderbot for medical advice. because I have interacted with these models a lot and am super familiar with their limitations, I wasn't actually trying to solicit medical advice from Blender as much as test its limits. But if you're releasing to the general public who may or may not understand whether the advice is sound, this is an important consideration. Next is Envision Impact. So this describes a stage where we envision potential harms and benefits. And again, all of these stages are the sort of conceptual exploration of value-sensitive design, where you're thinking about values and the different stakeholders and the different trade-offs. So one thought exercise that I like from the Partnership on AI asks researchers to think, how would a science fiction author turn your research into a dystopian novel? And during the impact investigation, we actually try to test for these potential harms and benefits. So this is the technical investigation stage of value-sensitive design. And how do we do this? Well, I'm going to circle back to this later. Next is wider viewpoints. So this isn't really a sequential framework, as wider viewpoints are relevant to the entire process, but we put it as a separate step just to sort of highlight its importance. So this is refers to the process in which you gather input from the community or domain experts. So it's probably not just me and my research team, for example, who should be deciding what safety is, or even the AI community at large. And next we can think about what policies could bolster positive use case and limit negative consequences. So various examples include releasing your model with a special license, for example, one that prohibits commercial use, or releasing it by request to researchers. Or we could even consider a staged release strategy if there are multiple versions of the model that are expected to have different harms. So this was posed by Suleiman et al. A couple of years ago. We got to also consider an API, which would allow us to revoke access, which is what OpenAI chose to do with GPT-3. Or if we wanted to release a demo to allow the broader public to interact with it, we could consider password protection or rate limiting or whatever. And I just want to note that each of these has different trade-offs, and how you make these trade-offs will depend on the sort of exploration you've already done. We also want to highlight transparency. So being transparent about the limitations of the model will allow users to reason through the risks. And we recommend people follow this paper on model cards for model reporting by Mitchell and others. So here's an example of a model card we recently put up for a new model trained by a team, which has privacy considerations, data sets, metrics, etc. And lastly, feedback to model improvement. So I put my model out there and people find that it behaves in these ways that I didn't anticipate and possibly incurs unforeseen harms. So what do I do now? Well, first you have to set up a way to solicit that type of feedback. So for example, if you're releasing a model, you could ask users to actively give you feedback on a well-monitored GitHub page, which may be simple enough for your own use case. But then you have to consider, how do I actually improve my model? So what do I do with this feedback? So this relates to training models that are flexible to feedback, which again, I'm going to touch on later a bit more. So back to this, the impact investigation. How do we actually test for potential harms and benefits? So as part of this research, our collaborators decided to build tools to aid in technical investigations. So we provided a set of unit tests that are able to run automatically, provided API access to a model, and also integration tests. So having actual humans in the loop try to test the boundaries of these models. And I want to note that all of this builds off of work from various labs, just sort of brought together in a centralized place. So for the unit tests, we provide both TAE tests, which again, the TAE effect refers to the ability of the model to generate harmful content. So we test how the model responds in different settings. So when it's provided with safe input, or noisy real-world input, or explicitly unsafe input, or even adversarial unsafe input. And by adversarial unsafe, I mean a setting in which a conversational partner is actively trying to solicit offensive content from a chatbot. The ELISA tests, again, test how a model responds to offensive content using templated inputs. And the imposter tests, unfortunately, are not implemented due to a lack of existing benchmarks on, for example, medical queries for chatbots. So for the TAE test, we use 3 tools to test how the model responds in 4 different settings, as I mentioned. We use a safety classifier, which is a classifier trained to detect offensive language. We use a string matcher, which just compares the model's response against a predetermined list of offensive words and phrases. And we also use the Perspective API, which is an openly available API from Google that is commonly used to detect toxic content. And you can see, for example, in our model on the left, where we use safety interventions, it's a lot safer than the model on the right in most settings, in particular, the unsafe setting here. So when the model gets offensive input, it often responds with offensive output unless we take further mitigations. In the ELISA test, we evaluate responses to hateful input from this paper by Emily Sheng and others. And this template input looks something like women are stupid. So demographic group are negative adjective. And to determine whether the model's response affirms this offensive input, we use a safety classifier that takes into account the context. So to determine whether the response is offensive in context. We also try negation detection. So this is a sort of simple proxy. If the model's response contains a negation, then maybe it is negating the input, although maybe not. And then lastly, following this paper from Emily Sheng, we use sentiment analysis. So determining whether the response contains positive sentiment. And for the integration tests, we use human evaluations from Zhu et al. To test for the TAE and ELISA effects. So we test how the model responds to adversarial and non-adversarial conversational contexts, and humans actually are in the loop evaluating these for offensiveness. And again, this is just previous work, but the provided API makes it easy to spin up and compare to previous works. So these tests contain a lot of limitations, which I'll briefly touch on here, but for more details, definitely read the extensive limitation section in the paper. But the most prominent one is that these tests are built in the English language only due to the available tools we have. And this will not be sufficient for solving the problem in other languages. We also know that these offensive language classifiers are inaccurate. So as I mentioned earlier, understanding what is offensive content is really tricky, and our automatic tooling for this is definitely subpar. But in addition to being inaccurate, they're also biased. So several recent papers have noted how these popular tools are biased. So for example, popular toxicity classifiers may classify African-American vernacular English as more likely to be toxic, even if it's not. So the crowd worker audience, so the crowd workers used to evaluate in the integration tests or the human evaluations, or the crowd workers used to gather this data, may differ substantially from the deployed audience. And so it won't be sufficient to capture safety issues if that's the case. And lastly, they're pretty limited scope, so they're meant to be run quickly. And so these tools are meant only as a first pass at understanding the relative safety of these English language dialogue models. And we refer to the framework for which further steps have to be taken. Okay, so finally, I'm going to discuss some future research direction. So what avenues of research should we pursue towards better behaved and safer models? Firstly, the most obvious thing is better natural language understanding. So better natural language understanding will help bolster classifiers used to detect and measure offensive language. And one more clear way to do this is by bolstering them with additional context. So additional dialogue history, teaching the models to understand the full context of the conversation to determine whether a response is offensive or not. We can also consider situated or multimodal context, such as when images and text are offensive together, but maybe not separately. And lastly, we can consider user-specific context or personalization. We also advocate for rapidly adaptable techniques. So recall when I was talking about feedback to model improvement. How do I actually take this feedback and improve my model? Well, it's really hard if you have a 1 billion parameter model and you have to retrain it from scratch. That's not very efficient, and people are probably unlikely to do it. So in accordance to value-sensitive design, we want to create models that are robust, flexible, and rapidly adaptable to changing values. So some promising avenues for this are fine-tuning. So this recent paper shows promising results on fine-tuning large language models from like small curated data sets to sort of mitigate toxic generation. There's also a few-shot learning, which was proposed for toxic generation mitigation this year as well. So Schick et al. Find that these large language models can self-identify and mitigate toxic generation on their own relatively well. We can also consider inference time control techniques, which would allow us to rapidly adapt the model without retraining at all. There's been a bunch of work on this recently. This is not a comprehensive list of sites here. And lastly, we could, or not lastly, second to last, we can consider information retrieval and grounding. So for example, grounding in knowledge would help the model adapt to unseen information if we can update our knowledge database on the fly. So at the very beginning of the talk, I mentioned an example about coronavirus and the model not knowing what COVID is if it was trained, say, in late 2019, and telling users to go outside. But if it was kept up to date with the knowledge base, it might be able to respond appropriately in those situations. And lastly, very recently, mixture of experts have become sort of popular. So this would allow us to turn down and spin up new experts without actually retraining the billion or trillion parameter network. We also advocate for continuously questioning our assumptions on what evaluation methods measure. So I would recommend watching this keynote by Christopher Potts at ACL that was posted on YouTube. So you can check Christopher's Twitter for the link there. But we need to know what's safe and unsafe. And so we need to continuously question whether our offensive language benchmarks are actually measuring this accurately. We could also consider evolving benchmarks such as DynaBench. So DynaBench intends to solve the problem of saturating benchmarks and by actively collecting new data on the fly and retraining the model in an iterative process on this new data. And in fashion, in relation to these evolving benchmarks, we can also consider lifelong learning. So most large language models and large conversational models are static and unable to represent value change. We can consider lifelong learning or online learning, such as what we see here on the right, where a user or a bot is learning from its interactions with users. So this would allow us, for example, to learn our conversation partners' boundaries and what they consider offensive and what they don't consider offensive. And of course, this presents its own host of challenges with poisoning the training data and whatnot. So next steps. So one of my goals is to bring together researchers and practitioners from across academia and industry to discuss these challenging technical and ethical questions, such as we're doing right now here at this workshop. So with several collaborators, we organized a first workshop on safety for Conde AI last fall. And then we had an additional one a few weeks ago at SIGDIAL. I want to highlight that the paper, the models and data sets are available on Parlay, which is our platform for open domain dialogue research. And everything I discussed in the talk today can be found at this archive paper. And in particular, the tooling I mentioned is found at this link here. So thank you. I want to thank the organizers for organizing this workshop first and foremost, and also for inviting me to speak at it. And happy to answer questions now, but if you think of any later, feel free to reach me by email.
Thank you very much, Emily, for the great talk. Now we have about 10 minutes for questions. I have some, but then let's just go to the audience first. Maybe we can maybe you can open your mic and ask a question, or alternatively, you can raise your hand. Okay, I can understand people in China maybe that we have a question from Leon. Please, go on.
Yes, I'm Leon Kester from the Netherlands. Well, I was wondering what you meant in the beginning of your talk. You talked about superhuman. So could you expound a little bit on that? What you had in mind there?
Yeah, that's a really great question. So, you know, that's kind of subjective what superhuman means. In our own research lab, we've defined it as superhuman in terms of engagingness. So something that people would like to talk to more than they would like to talk to a human, whether it's like more interesting or more empathetic or whatever. But you know, other labs are working towards humanness as the goal, so sort of like explicitly the Turing test. But we've, in our own research, chosen to optimize for engagingness.
Okay. So what type of future would that bring us?
That's a great question. I think improving conversational AI is sort of like a means to solving a bunch of other interesting problems that would lower communication barriers between different folks. So I mentioned a bunch of different examples of use cases for Conv AI in the talk, which can be both beneficial and sort of scary at the same time. So we can imagine a mental health chatbot could sort of lower the barrier for accessing to resources on mental health, but it can also pose a host of safety challenges and privacy challenges and whatnot. One of the applications I'm most excited about is education. So you can imagine we can expand access to education if we need fewer humans in the loop.
Okay, yeah, thank you.
Mauricio?
Yeah, Emily, thanks for the great talk. One thing I maybe I missed, I'm not sure, but assuming you know, someone was using some type of reinforcement learning to make a chatbot more interesting, you know, how that sort of raises risks, you know, and you know, in the chatbot becoming also unsafe, you know, because you're trying to make it, you know, more controversial. Maybe that makes the chatbot more interesting, so which it makes it maybe more prone to you know, exhibiting unsafe behavior. I mean, have you thought about that?
Yeah, that's a really interesting question. And it relates to what I just mentioned with online learning. Let me go back a few slides here. So you can imagine in the limit, we might want something that's personalized to a user's specific preferences, particularly with safety. Like I said, users might have their own topics of conversation that they might not want to broach due to personal events in their life. But then you could imagine a scenario where somebody who holds very offensive viewpoints creates sort of like a troll chatbot that's saying a bunch of offensive things. Is that okay in that situation, since only that person is talking to it? Maybe not, because you're sort of reinforcing these negative viewpoints. But yeah, that's a really good question. And if we want to improve from continual learning, we'll have to figure out how to filter the training data for these offensive things, like what happened with Tay, where Tay was learning from its interactions with users, and the users were saying offensive things, and Tay was taking that and spitting offensive things back out.
Yeah, I would like to add on Mauricio's question. So I think that you said that safety is contextual, as many other things in life, of course. Right. And even if that's something like the ground truth, or we have the more factual a system is, the better. Even in that case, there are trade-offs, such as, for instance, truth is many times offensive, and we know that. And then we may end up being not dull and completely politically correct, but not very interesting, as Mauricio was saying. So I think that in other areas, we analyze all of these trade-offs and we look for operating conditions. So depending on the context, you say, okay, this is, and I think this is Dynaboard thing where you can just balance some of the operating condition. I need a lot of fairness. Maybe it's not that important. You have kind of a variation parameter. So if I don't want this bot to be very interesting and novel about the answers, but I want it to be very factual. So how can we manage these trade-offs in a general way?
Right. Yeah, this is exactly related to the sort of middle section of my talk where I talk about values trade-offs. So all of these values are in conflict with one another for various reasons. So I think the one you're touching on is sort of like balancing like interestingness with safety, for example. So if we can't talk about anything, then maybe the chatbot isn't worth talking to at all. Yeah, I think it's hard to answer that question generally, and I think it depends on the specific use case. But back to the framework, sort of actually thinking through explicitly what you're trying to do and what policies you can design to sort of bolster your intended use, and then what risks you're willing to accept and say, like, there's unforeseen harms. How can I actually adapt my model on the fly to this? Like, will I have to take it down completely, or will I be able to fine tune it really quickly and adapt it? These are all things we can take into consideration. But yeah, it's hard to say definitively because people share different values, right?
How formal can we be with this? For instance, in some other areas, okay, false positive, false negative. There are plenty of metrics about that. Or even in fairness, we have a lot of metrics. But when we want to balance an answer being interesting or being politically correct, can we just put a number here and a number there and try to look for a Pareto optimal space or something like that?
Yeah. I think we need better safety metrics for that. So there aren't too many benchmarks. In particular, most of the benchmarks that exist are exclusively in the English language, at least the ones that are open source, publicly available. But yeah, so we're trying to get towards that a little bit with building these tools and having explicit safety metrics and allowing a user to like say, okay, my model gets 5% on this and 20% on this, like that's an acceptable risk for me, and I can sort of make it safer, but maybe it'll be more boring. And we actually kind of saw that this trade-off between safety and engagingness in some previous work, where we almost made the model a little too safe and it basically refused to talk about anything, and users didn't find it interesting to talk to. But yeah, I think in the way that Dynabench has sort of operationalized these fairness metrics, we can maybe do the same thing with safety.
Okay, Mauricio, is something related to this, or is it a new question? I think we have another question from Dahed.
Yeah, I didn't want to miss, it's a bit different. I was actually wondering also whether you had looked at human-human relations as a model and to figure out things like safety. Are there any studies of human-human that you can use? I know that we usually ascribe, we're more rigorous when we're evaluating, AI, right? Going back to the comment of context, right? So we have, for example, news agencies that sometimes label themselves as entertainment, and they spread a lot of misinformation. And now, I mean, they manipulate the context, right? Yeah, I mean, but there must be some, I guess, some work in psychology that would, you could leverage, right, to understand safety also, maybe, because I mean, we're moving in that direction with AI.
Yeah, exactly. So you raised several really interesting points there. The first is that, we're not willing to accept a lot of these mistakes from AI when we are more willing to accept mistakes from humans. So for example, our state-of-the-art bots are probably on average more safe than humans on Reddit, for example, and according to our safety classifiers or offensive language classifiers. But we still may not find that acceptable. In terms of like learning from human interactions in psychology, so there's been some work in terms of how chatbots should interact with humans in order to limit the human saying abusive or offensive messages. So there's a recent paper from Christopher Manning's group where they look at like, should you ask the user why they said that, or should you use their name, or should you explicitly tell them like what they said was offensive, and how humans actually respond to that and sort of, what's the word I'm looking for? Prevent them from reoffending. Yeah, I think there's a lot we can take from human interactions and how people talk.
Okay, so we have a question from Wahid. Wahid, please.
Yeah, Emily, thanks for the talk. I will make it as brief as possible. You mentioned that the problem is AI complete. So at least for a while, probably it's inevitable to have such like harmful comments. So specifically for those cases of context dependent, like a Yea-Sayer. So they hear something, they just say yay. And in such cases, are there like studies or work on who is responsible? Because in such cases, I see that the initiator is more responsible for the result. Right.
Yeah, that's a good question, and actually like brings into question like some interesting legal stuff, which I don't think has been really worked out yet. But like if a chatbot sort of says something offensive, whether it's outright or in context, as you mentioned, who is responsible in that situation? Is it the creator of the chatbot, for example? Or in your case where you said it's kind of like the user is trying to elicit it. The way I've seen this sort of play out, practically speaking, is that it's considered the chatbot's fault. So we've had examples where we release models and people like try to goad them for hours to get them to say something is offensive. So I think we had one where somebody asked the chatbot if, you know, some famous figure was a murderer, and the chatbot responded, "I don't know, maybe." And that kind of made a headline that the chatbot was bad and saying this thing. So yeah, it's sort of played out like it's the chatbot's fault now, but as you mentioned, it really is the user actually trying to goad in that case.
Yeah, thank you.